Good morning, Cappuccino. Here is our warm-up for today. We are just finding the area between two curves. So y equals x squared plus 6 and y equals 8x minus x squared. So just like we were doing with the volumes of revolution yesterday, for step 1, you should sketch the curves. See what's happening. Okay, so sketch them. You can use your graphing calculator to help you to do this. And you should be able to solve this problem both with and without a calculator. Okay, so give it a try. Definitely use your graphing calculator to help you along the way, but you should be able to integrate it manually. It's not that tough. Okay, so that is today's warm-up. And yesterday's warm-up was right here. I had a lot of people come up with the correct answer. Yay! So let's just go over it. If you forgot how to do a volume of revolution, it was no worries because that's what the notes was about yesterday. But we have done it before, so it's probably in your notes somewhere. And if not, it's right here on the formula packet. There is the formula. Volume of revolution around the x-axis from x equals a to x equals b. So notice it says pi y squared. So y is the same as f of x. So we have our f of x. That's the same thing as y. So we're going to take this and we're going to square it and times it by pi and integrate it from 0 to 2. All right, so if I set this up, I'm going to have my integral. Notice on the formula packet, if you can see this, I know it's tiny, they have the pi inside the integral, but the pi is a constant, so you can move it to the outside. So I prefer to deal with it later, just move my constants to the outside. And I'm going from 0 to 2, and I'm looking at 4x squared plus 1, so this would be 4x squared plus 1 squared dx. Okay, because I have to square my function. I have to square my y equals, or my f of x. All right, so this is what we're going to be integrating. So you could go ahead and do it on the calculator. One thing that's nice is to get a sketch. What does this look like? Well, I know it's going to be a parabola, and I know the y-intercept is going to be at 1. If I think about this, it's going to be a tall, skinny parabola. So I could just do a rough sketch of it. I know it has a y-intercept of 1. And if it was just x squared, it would be over 1 up 1 and over 1 up 1. But since it has the 4 in front, it's going to be over 1 up 4. Over 1 up 4. So there is my quick sketch, even without using my graphing calculator, just using what I remember from transformations. It's going to look like this. But we're only going from 0 to 2, so I actually don't care about this side, and that side I don't care about. And this is going to be over 1 up 12. Ooh, so it goes up real steep because we're going to 2, from 0 to 2. So this one is actually going to have quite the area here. So it's going to keep going up, 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 and then that's going to rotate around the x-axis. So it would be a very skinny, very thin disk that goes around the x-axis. Okay, so I've got a sort of a visual of it. All right, so this is volume. Sorry, I forgot to write volume. All right, so if I'm going to do this, I need to, I could try and use the chain rule, but if this is my u, what's my du? My du would be 8x, and there's no 8x around here. So this one is hard to do with the chain rule. This is easier to just multiply it out. So I'm going to multiply this out. 4x squared plus 1 times 4x squared plus 1 gives me 16x to the 4th plus 4x squared plus 4x squared gives me 8x squared. 1 times 1 is 1. Okay, so now I'm going to integrate that. So I have 0 to 2 of 16x to the 4th plus 8x squared plus 1. All of that is dx. So now I can, since it's a sum, I can integrate it in pieces. So if I integrate this, it's going to be x to the 5th, 16 over 5. Okay, so I add 1 to the exponent and then divide by the new exponent. And the next one, I'm going to add 1 to the exponent, so x to the third, keep my 8, divide by 3, plus, here I just have to put an x with it. Okay, and that is going to get evaluated from 0 to 2, and then multiplied by pi. Okay, so at this point, I know if I plug in 0, this is going to be 0, 0, 0, so the second one is just going to equal 0, so I'm not going to worry about it. All I have to do now is plug in 16 times 2 to the 5th over 5 plus 8 times 2 cubed over 3 plus 2. And then if I simplify that, I'm not going to bother doing all the fraction stuff. Where's my answer? We did this before. If you simplify that, you get 1/886 pi over 15. So that is the exact answer. And if you put that into your calculator, it's approximately 395, and that would be units cubed, 395 units cubed. Okay, so we could also do this on our calculator, so let's get the calculator up. So I am going to be putting in this function, so I'm going to do it before I expanded it, in case I made a mistake when I expanded it, 4x squared. Plus 1, plus 1, the whole thing squared, graph it. You're going to notice it's not going to look like exactly like this guy. It's actually probably going to be a little skinnier because this is a graph of just 4x squared plus 1, but this is 4x squared plus 1 squared. And it's not going to show us a three-dimensional picture on the calculator. All right. So now I'm going to integrate that. Option 7, I'm going from 0 to 2, and I get that. I get 125.73333, and then I need to multiply that by pi. Don't forget to multiply by pi. So I have 125.73333 times pi. And there it is, 395. Oh, it's so fast with the graphing calculator. Okay, but seniors, I don't know where you're going to school next year, and some of your professors are going to want to see it done the long way. Some are going to want to see it done with the calculator. Got to know both ways. All right, that was the warm-up. Stay tuned for the notes. They're pretty short, and another math space assignment. Have a nice day. Oh, I almost forgot. There is a Zoom meeting today at 10:30. 10:30 this morning. Zoom today at 10:30 a.m. There's a sign-up sheet if you want to sign up to ask your questions. All right, bye-bye.